Hello, everyone. Today we're going to talk about monitoring strategies. We'll talk about the current strategies that are available. We'll identify what needs to be monitored. We'll look at how performance should be monitored in cloud environments, and we'll look at some key system metrics. As we mentioned earlier, service level agreements are a written agreement, a contractual agreement between a cloud provider and a cloud customer that outlines what needs to be monitored, what needs to be measured, and what needs to be reported. In order to be in compliance with service level agreements, it is important to monitor certain things, such as the things that are listed here: response time, uptime, privacy, security, and regulations, compliance. Cloud-based systems are a conglomeration of multiple components, as we know. Each one of those components can be a single point of failure. Each one of those components needs to be monitored. Also, there are certain job functions and job descriptions that will dedicate their time to looking at certain things, such as a front-end developer, for example, will look at the times, how long it takes for a page to load, what kind of performance is happening across the network. Are the APIs, the application programming interfaces, creating a bottleneck? Are they efficient? Are they responsive? Database architects might look at threads and how long it takes for a query to be performed, any caching and memory and CPU utilization. Basically, if we're talking about transaction processing, which in most cloud environments we will be talking about cloud-based, web-based transactions, then we need to understand the importance of the database and how it is designed for efficiency. We need short, sweet queries, and we need tables that are well-formed. System administrators are probably going to be looking at requests per second, disk space utilization and capacity, CPU and memory utilization, similar to the database architects. The product owner will look at the unique visits per day to their sites, any new users, the cost per user, the number of products that are actually sold, things like that. As we talked about in the previous chapter, there are 4 layers of a cloud stack: the user layer, application layer, application stack layer, and the infrastructure layer. Each one of those layers will have its own set of requirements for monitoring. And so it is important to understand the functions of each layer and how each layer communicates with the layer below it or above it. And that can be an important window into how we can monitor the security and all other performance, all other aspects of a cloud environment. Typically, there are 3 distinct domains. The cloud vendor will have a certain domain. The cloud application, for example, Infor CSI, there will be a certain environment that is available for that application. Each time we logged on, we used a certain environment as we were doing our exercises. The user experience is another domain, and some of those can be controlled. The user experience may or not be something that can be controlled, but we can certainly monitor not only what's happening at the cloud stack, but what is happening with the users. What we need to monitor? Well, performance, certainly, the number of new customers, the unique visitors per day, the number of page visits per day, the average time spent on a site, revenue per customer, the bounce rate, which is the percent of users who leave without looking at a page. So you log onto a page, but you don't actually look at anything. That's the bounce rate. The conversion rate, the number of users who actually follow through based on some promotions, direct marketing. What is the conversion rate? Is the promotion or the new strategy, the direct marketing strategy, is it successful? Throughput, which is very important to users. How long does it take for the page to load? The uptime, how often is the site down? Most e-commerce sites cannot stand any downtime. The response time for application programming interfaces for middleware. How long does it take to generate a report? How long does it take to get a response to a query? The transactions per second, the requests per second. All of those things are going to be important to the users. If we go to a site that is taking too long for the page to load, the site is frequently down, the response time is slow, the likelihood of us continuing to be customers at that site is very slim. We are customers that are expecting immediate gratification. Quality, the success and accuracy of user registrations, the percent of failed deployments. If you have new upgrades that need to be deployed, how often are those successful and how often are they failure? How often are they not successful, rather, how often do they fail? The error rates, are there a lot of errors in the error log? Looking at the error logs and monitoring the logs is very important. Is there a specific type of error that shows up consistently? Key performance indicators such as revenue per customer, revenue per hour, the number of incoming customer calls per day. If you're working in a call center, that could be useful. The number of jobs completed per day. If you're running a big system, you're running multiple jobs, how many jobs are completed during the day. The amount of site traffic. The shopping cart abandonment rate. How often do you go to a website and decide to purchase something but simply add it to the shopping cart and then log off without closing the transaction, without completing the transaction? That is shopping cart abandonment rate. It is very important for customers, for vendors, and for businesses that are in e-commerce retail organizations specifically to see how many times the shopping carts are abandoned. Security, as we mentioned in the previous chapter, security is very important. How many failed authentication attempts for each component at each layer? Now, typically, if there are policies in place, and that goes along with compliance, if there are policies in place, there will be a threshold for the number of failed authentication attempts, maybe 3, maybe 5, before that account is locked out. And that's a safeguard, because if people are constantly trying passwords and trying to guess passwords, then the number of authentication attempts would be an indicator that somebody's trying to breach the system. The user, the system, or an IP address that's constantly failing to authenticate probably should be blacklisted and blocked. Any unattended scripts or bots should be detected and destroyed. You can set up, sometimes in routers there are programs that can detect if somebody's trying to run an .exe or an executable file, and will kill that file and prevent it from executing. Blacklist IP addresses that are trying to authenticate failed authentication attempts. Block those IP addresses so that they cannot do any damage. And then, of course, security audits periodically, monthly, bi-yearly, or yearly are a good idea. Compliance. Policies that are in place, which will usually set up permissions for users and who can access what. Background checks on employees. This is becoming more important because most of the security breaches, as we have discovered, are caused by employees and or contractors. Background checks, while they cannot prevent security breaches from employees or contractors, they can certainly go a long way towards reducing the number of security breaches from employees with a thorough background check. Restrict access to the buildings. Only those who need access should be able to gain access, and the same with production systems. If you have employees that are in the building but they don't need access to the systems, then make sure those systems are safeguarded and locked so that only certain people who need the access can have the access. A review of the log files is always a good idea. Monitoring the log files can tell you what type of errors are happening, what the performance looks like, who is trying to access what, when users are accessing and logging on, what are the peak times, what are the slow times. There's tremendous information that can be detected from the log files. A monitoring strategy must be in place, and it must be continuously improved over time. There is no perfect monitoring strategy, but you can certainly go a long way with monitoring to reduce the number of problems, security breaches, performance issues, and things of that nature by leveraging a combination of software as a service solutions and open source solutions, or maybe perhaps internal or proprietary solutions that have been developed in-house. An in-depth understanding of cloud architectures is critical because you need to be able to monitor at each level of the cloud stack. This has been the discussion on monitoring strategies.